The clips that I choose are very purposefully selected in an attempt to help you learn easier and faster. Each clip tries to exemplify a specific principle or trait that I want to help you notice and understand. Once you understand a principle in one movement, it's much easier to visualize, apply, and extrapolate that understanding to others. So in the words of the renowned samurai and master swordsman Miyamoto Musashi,
"To know 10,000 things, know one well."
it is my belief that in order to know many things, it is best to spend time learning and understanding the fundamental principles that connect those things. If you don't know how to balance a rock, I strongly recommend pausing the above clip as it changes and reading the tips, because it will give you extraordinary insights into the nature of balance and stability for something so seemingly simple. The same concept of balancing this rock can be applied to balancing on one foot. Our foot is also a tripod. So finding a point for your center of mass to sit within your base of support is all it takes to find a point of balance. Stability factors in the ability to resist disturbance. That we'll talk about in more detail later. The human foot is in essence a tripod itself. It is engineered to be a lot more adaptable, but the principle of balancing and finding stability on your foot, especially if standing on one foot, remains very much the same as balancing this rock. Our feet are quite literally the foundation on which our structure and balance stand. So we're going to spend a moment and just cover a quick overview of how they function. So one of the most important design elements we're going to focus on quickly is the fact that the human foot is designed in essence like a tripod. Now the structure of the bones, ligaments and connective tissue are arranged in a fashion that makes use of the properties of arches. Now the study of the human foot can be quite in-depth. I don't want to go into too much detail, but what I do want you to take note of is that the human foot is in essence a tripod, and it is arches that give it its fundamental properties. The structure of the human foot is very unique in the sense that it can adapt depending on the terrain and the forces applied to it. So the structure of the arches can actually change shape to be more efficient at dealing with different terrains, slopes, angles, irregularities, and even different angles of force and weight. It's an amazing structure. The arches in the human foot have several adaptive functions related to balance, stability, force generation, and shock absorption. Here's a brief explanation for each. Balance. The arches help maintain balance by distributing weight across the foot. The arches act as flexible structures that dynamically adjust to different surfaces and terrains, providing stability and preventing the foot from rolling excessively. Stability. The arches enhance stability by acting as natural shock absorbers that distribute forces during walking, running, and other weight-bearing activities. They help to evenly distribute the body's weight on the floor as well as through the anatomical structures of the foot and lower extremities, reducing the risk of injury or strain. Force generation. The arches aid in force generation by effectively storing and releasing energy during locomotion. As the arches compress and stretch with each step, they accumulate and release elastic energy, creating a spring-like mechanism that contributes to efficient movement and propulsion. Shock absorption. By serving as organic and adaptive shock absorbers, the arches are essential for shock absorption. They help absorb and dissipate the impact forces generated during activities such as jumping or running, reducing the strain on bones, joints, and soft tissues.
Foot arch is able to adapt to differing surfaces, behave as a shock absorber, and also stiffen up to propel the body forward during the push-off phase of each step. The muscle, plantar fascia, ligaments, and tendons in the feet all form a robust base in the form of an arch in which all this can occur. We could therefore think of the foot arch as a foundational pillar of the body.
The height of your arch, or lack thereof, is not a determining factor in foot health for a large majority of people. It's all about how the arch functions, not its appearance. Having low arches doesn't automatically lead to foot problems. However, having low arches in weak feet can. So a lot of people that think that they have flat feet often just have low arches that are very mobile and flexible, and they would benefit from things that strengthen their foot. You see, going barefoot more often can enhance your foot stability, and better foot stability leads to better lifting technique as a whole. You see, when you cram your toes together within a narrow shoe, it's far easier to lose foot control and allow the knee to cave in as well. But if we're able to spread your toes out by going barefoot or wearing a shoe that mimics going barefoot, the foot can function as it was designed, maintain better stability, better arch control, and therefore less room for knee instability. The transition to going barefoot more often and wearing barefoot style shoes is something that I promise you can benefit your life.
Walking barefoot is one of the most simple and effective ways of strengthening and mobilizing your feet. Because take a look at the rocks. As we walk over the rocks here, notice how the whole foot is molded and shaped and is dynamic in the way that we move. This helps strengthen and mobilize the feet and ankles.